Hello, good morning my dear students, and once again, welcome to the world of electronics. Our lesson for today is taken from lesson 2 of module 3 under LX111, which is electronic devices, instruments and circuits. The lesson is all about capacitors, their characteristics and applications and the circuits. There are two kinds of capacitor. These are the fixed capacitors and the variable capacitors. Variable capacitor has two types. These are the tuning capacitor and the trimmer capacitor. Fixed capacitor has several types. These are electrolytic capacitor, aluminum, electrolytic capacitor, oil impregnated, electrolytic capacitor, tantalum, electrolytic capacitor, polymer aluminum, super ultra capacitor, electrochemical, electrolytic capacitor, non-polarized, polystyrene film capacitor, polycarbonate film capacitor, mylar film capacitor, ceramic disc capacitor, polyester film capacitor, polypropylene film capacitor, metallized ceramic disc capacitor, metallized polypropylene film capacitor, air capacitor, epoxy film capacitor, silver mica capacitor, polypropylene film capacitor, and SMD or chip capacitor. For your information class, capacitors are among the widely used electronic devices and electronics technology. If we try to scan this electronic board, this is an electronic board of LED TV. There are 1, 2, 3, 4, 5, 6, 7. There are 7 electrolytic capacitors, aluminum. Then there are 1, 2, 3, 4, 5, 6, 7. There are also 7 metallized ceramic disc capacitor with 1 ceramic disc capacitor. There are also 2 pieces of metallized polypropylene film capacitors with several SMD or chip capacitors. So we have here, to make it clearer, for this electronic board of digital multimeter, the digital multimeter electronic board uses, there are 6 electrolytic capacitors, aluminum, with ceramic disc capacitor. Then, there are lots of SMD or surface mount devices or chip capacitors. We have here an example of chip capacitor. This is actually made of tantalum electrolytic capacitor. So we can determine that this is capacitor because adjacent to its body is indicated with C9, meaning to say capacitor 9. So we have also here miniaturized SMD or chip capacitors. We have also SMD or chip transistors, diodes, SMD diodes, SMD resistors. There are lots of resistors also. We can determine that these are resistors or chip resistors because adjacent to its body is marked or printed with R29, R30. So these are chip electronic devices or SMD, surface mount devices, like SMD capacitor, SMD resistor, so on and so forth. Okay? For this electronic board of computer, the CPU board, there are lots of electrolytic capacitors, aluminum. And we have also electrolytic capacitors, polymer aluminum, electrolytic capacitor, polymer aluminum, electrolytic capacitors, aluminum. Then, there are lots of chip capacitors or SMD. So, it is very hard for us to see them because they are being miniaturized. No? They are made smaller. Okay? So, what are these capacitors? and how these capacitors behave in electronic circuitries. Capacitor is an electronic device designed to store electrical energy or voltage. In other words, capacitor is similar to a battery. Okay, let us prove. We have here an example of capacitor. Electrolytic aluminum capacitor with a capacitance of 2,200 microfarad and a working voltage of 50 volts. So, let us try to measure if there is stored voltage here. So, we will set this analog voltmeter to DC voltmeter. We set this to 50 volts range. Then, let us connect the two test pads to the two terminals of this capacitor. So you see, so let us short to totally discharge the voltage here. Again, so 0 volt. There is 0 volt. Okay. So this capacitor now is not stored with voltage. So let us try to store it with voltage from this equipment. By the way, this equipment is an AC-DC power supply that provides variable DC voltages at the output. We have here the output line. We have here the negative side. At first, let us set this to, we will set this to 25 volts. Okay? The negative side of this power supply is connected to the negative of this capacitor. Then the other terminal is connected to the positive side. Okay? After a few seconds, probably, the voltage now is full. So whatever the voltage given here is 25.4 volts. So the voltage also that will be stored here is the same, 25.4 volts. Okay? Let us now measure if there is already voltage here. The negative here of the DC voltmeter is connected to the negative side of the capacitor. With respect to this positive side to the positive also of the capacitor. So there is voltage here. The reading now is 26 volts, the same, or 25.4 volts. No? Okay? If it is inverted polarity, usually the pointer deflects backward. Meaning to say it is reverse polarity. It should be like this. Okay? Positive side connected to the positive of this capacitor, and this negative side of the voltmeter is connected to the negative side of the capacitor. So it reaches here 25.4 volts or 25 volts. So meaning to say, this is now with stored voltage. So let us try to discharge this. See? Now the voltage is discharged. If we try to measure the voltage here to prove that there is no more voltage here, again, measure. So there is no more voltage. Almost zero. So, short. No more voltage, 0 volts. Now the stored voltage provided by this power supply is totally discharged by shorting it with a conductor. No more. Okay?